Atlantic salmon use rivers and streams for part of their life cycle, which includes adult migration, spawning, juvenile rearing, and smolting. All these stages require fish to be able to both reach and then to move between different habitats. Therefore, connectivity between habitats is essential for Atlantic salmon and many other species of aquatic organisms to complete their life. Healthy streams have intact processes that help to maintain these diverse habitats. Most healthy river habitats are naturally dynamic and change over time. This includes rivers continually moving and eroding both laterally, which means sideways across the floodplain, and vertically, which means up and down the banks within their channels. These processes ensure that groundwater inputs are maintained, that woody material enters the channel to create important habitats like log jams, and that sediment and nutrients can move downstream. Many aquatic species, like fish, crayfish, snails, and arthropods, and terrestrial species like amphibians and turtles, require a diversity of habitats. By allowing natural processes like erosion, flooding, and tree falls to happen, we can help ensure this diversity of habitat types is maintained. For adult migration upstream and smolt migration downstream, Atlantic salmon require rivers and streams that are free of man-made obstructions, such as dams, weirs, or perched culverts. Dams can completely block upstream migration, preventing adult salmon from reaching spawning habitats, and can injure smolts traveling downstream over the dam. Many dams also have a head pond, a slow-moving pool of water at the upstream end of the dam that can confuse smolts due to the lack of current, thereby delaying their downstream migration toward Lake Ontario. These head ponds also often warm the water, reducing the quality of salmon habitat downstream, and prevent the movement of stream sediments, woody material, and nutrients, disrupting the natural flow of this material and causing negative changes to downstream habitats and ecological communities. Even when fishways are present, they are never 100% efficient and often are not built for non-jumping species, which are basically anything except salmon and trout. This can isolate populations above obstructions in the river from those below obstructions. Even a small jump may be impossible for most fish species. For example, in most Lake Ontario tributaries, white suckers are adfluvial, meaning they live in Lake Ontario and migrate up tributaries to spawn. These spawning migrations bring large quantities of food resources and nutrients that are then available for juvenile salmon and other fish, supporting better growth rates and survival. Because white suckers don't jump, even dams with fishways sever this important seasonal food and resource supply. In the Lake Ontario basin, there are currently hundreds of obstructions on tributaries, many of which have no functional purpose. Juvenile Atlantic salmon rear in rivers and streams for 1 to 3 years before they smolt and migrate downstream to Lake Ontario. Their habitats must include appropriate shelter, food, and space, and these require different components of streams, namely riffles, runs, pools, and estuaries. These requirements change across seasons, across years as the fish grow larger, and depend on the size of the stream or river. With the reduction in tree cover and increase in urbanization, many parts of streams are warmer than they used to be. Salmon and other cold water species also need connectivity so that they can seek out cool water refugia during hot summer days. Adult salmon can actually create habitats that support juvenile productivity. Spawning adults dig spawning nests called redds. These redds are usually built in the gravel of riffles, and the act of digging alters the riffle's slope and depth, creating more diverse microhabitats than would have been there otherwise. Spawning salmon can also move fine sediments out of the spawning gravel in a process called bioturbation, enhancing the quality of the area for other species, like other fish and benthic macroinvertebrates, which also act as food resources for juvenile salmon. In order to maintain healthy stream processes and ensure that Atlantic salmon have access to all the habitats they need to complete their life stages, The program has helped complete many stream connectivity projects. Here are some examples. On Centerville Creek, a tributary of the Humber River, a 5-meter-high dam built in 1965 blocked the movement of all fish and impounded water and sediment in a large head pond. Removal of this dam opened up 19 kilometers of habitat and eliminated the warm surface pond water. This multi-million-dollar project is an excellent example of the health of the watershed being placed over human desires for a recreation area. In the headwaters of Coburg Creek, cattle were accessing the creek to drink water, and in the process were destroying the banks, displacing the gravel, and depositing waste which increased nutrient loading in the creek. By fencing off the stream, the cattle were contained in the field and were provided with an automatic watering device. On Mitchell's Creek, a tributary of Duffins Creek, an online pond was warming the water. A 420-meter channel was dug around the pond to bypass it. A wetland complex was also established in the adjacent field to help absorb rainfall back into the ground. The surrounding area was planted with native shrubs and trees, including live willow stakes, to quickly stabilize the stream banks. This project improved access to over 2 kilometers of habitat upstream. Also on Mitchell's Creek, an old golf course culvert was deteriorating and blocking the water flow and movement of fish. By removing this 10-meter by 6-meter cement bridge and culverts, sediment could again flow downstream, and fish could migrate upstream more easily. On Urfie Creek, a tributary of Duffins Creek, there was an old concrete weir that no longer served a purpose. Water was flowing around it, and woody material was accumulating behind it, impeding fish passage and the flow of nutrients and other material. Additionally, a stormwater management pond in a neighboring subdivision was discharging into the creek through a surface swale, or shallow channel, that was eroding away. The swale was stabilized, the weir was removed, and trees were planted to help stabilize the soil. Thanks to all our partners who are working together to increase connectivity for Atlantic salmon and improve watershed health across the Lake Ontario Basin.